Glikogenesis. Glucose is phosphorylated to glucose 6-phosphate in the liver by glucokinase. Glucose 6-phosphate is isomerized to glucose 1-phosphate by phosphoglucomutase. Glucose 1-phosphate reacts with uridine triphosphate to form the active nucleotide uridine diphosphate glucose, catalyzed by uridine diphosphate glucose pyrophosphorylase. The UDP glucose will be attached to the glycogen primer. The process is catalyzed by glycogen synthase. More UDP glucose will follow the same process that will lead to the elongation of 1,4-glycogen chain.
Carbohydrates, or carbs, break down into glucose, which is carried by the bloodstream to various organs of the body. Insulin is a hormone produced by beta cells of the pancreas and is necessary for glucose intake by target cells. In healthy people, beta cells of the pancreas produce insulin. Insulin binds to its receptors on target cells and induce glucose intake. In type 2 diabetes, the pancreas produces enough insulin, but something goes wrong either with receptor binding or insulin signaling inside the target cells. The cells are not responsive to insulin and therefore cannot import glucose. Glucose stays in the blood. In other words,
regardless of the underlying cause of diabetes mellitus, blood glucose control is disrupted and glucose builds up in the blood to abnormally high levels, making the person hyperglycemic. Although there is excess glucose in the blood, the glucose cannot enter the cells and the cells are starved for energy. The liver recognizes the cell starvation and initiates glukoneogenesis, further increasing blood glucose levels. In hyperglycemia, glucose that should be used as energy within the body's cells is instead excreted through the kidneys in the urine. This is called glycosuria, a common sign of diabetes. Unable to utilize the blood's glucose, the insulin-deprived cells, starved for energy, begin to metabolize protein. This leads to the loss of intracellular potassium and phosphorus and to excessive liberation of amino acids. As osmotically active molecules of glucose remain at elevated